Hello guys, in this video we are going to learn how to solve equations in quadratic forms. We already know how to solve quadratic equations, and in fact we can use all the times the quadratic formula, which we always work. We can always use completing the square, and many times we can use factoring. If it works, it represents the faster strategy, but keep in mind that factoring many times is not going to work. Okay, so what's a equation in quadratic form? Now, it's not a quadratic equation, however it can be written in terms of a quadratic equation. If you look at this first example, this is not a quadratic equation. Look at the exponents. Here we have a 2x squared, and this amount is in parentheses and is raised to the power of 2. So x squared raised to the power of 2 means x to the power of 4. So this is a polynomial degree, it's a polynomial equation of degree 4, which means we can get up to 4 solutions. And therefore is not a quadratic equation, it's a fourth degree polynomial equation. So in order to solve it, we can make a smart substitution, and with this substitution we can rewrite this in quadratic form. So quadratic form means that we can rewrite this equation in the form a y squared plus by plus c equals 0. I'm using y instead of x because I won't confuse this y with the x that is in our equation. And let's do a comparison between the equation that is given to us and the one that I wrote in red. So by comparison, a is the number, well, I'm sure we all agree that the c is this number by itself, so it's going to be our 35. Okay, so I'm sure that we agree that this is c, right? That's our c. What do you think is going to be b? Well, the only number we have here in front of this parenthesis is 36, so this must be b, and a should be the number in front of this parenthesis, which is 1. Okay, it's an hidden 1 here, so let's call this a. So I want to rewrite this in terms of y squared plus by plus c. So we know what c. What do you think is y? And this is the key step in this process, is recognize the value of y. And then by comparison, y is the number next to b, so it needs to be this. It needs to be 2x squared minus 3. And notice how this 2x squared minus 3 is squared, so this must be y squared. Okay? I think that this is the most challenging step, is also the key step of this process. Once you recognize what's y, the rest should be straightforward. Okay, so we identified that y is equal to 2x squared minus 3. So I will write this on the side and keep that in mind. Okay, you need to keep this until the end. Alright, so now what we can do is rewrite this in terms of quadratic equation, which is 1y squared, so just write down y squared. The b is 36, so I'm going to keep 36, and then we have y plus 35 equal to 0. So that's a quadratic equation that we know to solve in terms of y. We can use factoring in this case. If not, we're going to use the quadratic formula completing the square. But in this case, factoring will work. We need to find two numbers whose product is 35 and whose sum is 36. What are these two numbers? Well, these two numbers must be 1 and 35, because the product is 35 and the sum is 36. We can use the shortcut since the value of the leading coefficient is 1, so we can write this as y plus 35 times y plus 36, and this is equal to 0. Okay? The solutions from here are going to be y equal to negative 35 or y equal negative 36. Sorry. Oh, no, it's not 35, 36. Sorry. It's 35 and 1. I don't know why I wrote 36. Sorry about that. So it's 35 and 1. Let me fix this. Alright, so it's y plus 35 times y plus 1 equal to 0. So y equal negative 35 or y equal to negative 1. Okay? Now, you may think we are done with this, but we only solve for y. Now we need to solve for x, which means we need to come back to this substitution. which is y equal to x squared minus 3. So from the first one, we know that y is 2x squared minus 3, and this must be equal to negative 35. And for the second one, we have 2x squared minus 3, which is equal to negative 1. So let's solve this equation. We can get x squared by itself. So from the first one, we have a 2x squared equal to negative 32, right? We can divide both sides by 2 to get x squared equal to negative 16, take the square root, and put a plus and minus in front. So we end up with x equal to plus and minus. Well, the negative becomes I, and the square root of 16 is 4. So plus and minus, you can say I times 4 or 4i, which is the same thing. And then for the second one, we have a 2x squared, if I add the 3 on both sides, equal to 3 minus 1, which is 2. So we get x squared equal 1. We take a square root, put a plus and minus, so we get x equal to plus and minus 1. So there is no I in this case because it's the square root of a positive number. Okay? This is a I here. Alright, so the solution set is what? Well, we found 4 solutions, which is reasonable because this is a 4th degree equation. Okay, so we got 2 imaginary solutions, negative 4i plus 4i, and then we got the negative 1 and positive 1 that are the 2 real solutions. But we got a total of 4 possible solutions. Okay? Alright, so let me show you some other example. This is a little bit more challenging here, okay? Alright, let's see what we can do. Now, first of all, remember our goal. We want to rewrite this in the form ay squared, that's our goal, ay squared plus by plus c equal to 0, okay? So notice how we need to set up this equal to 0, which means we probably need to subtract. Before we do any substitution, we should subtract this right hand side, move it to the left hand side, so this is going to become a negative 3 w to the power 1/3 minus 2n equal to 0. Okay, by comparison, let's start with c. What do you think is going to be c? Well, c should be the negative 2n. What do you think is going to be b? B must be the other number, which is negative 3, and a must be equal to 2. So what do you think is the y? The y is the value next to b, which is w to the power of 1/3. So this must be y squared. So that's y squared, and this is y. Okay? So let's write here our substitution. We know that y is a w to the power of 1/3. And we're going to come back to this at the end to solve for w. Okay? Alright, so now what we're going to do is rewrite this in terms of a quadratic form. So 2y squared minus 3y minus 2n equal to 0. And we can try to do this by factoring. We need to find two numbers whose product is negative 40 and whose sum is negative 3. And it looks like a negative 8 and 5 will work. I cannot use the shortcut because there is a leading coefficient of 2. So we need to use the long process. 2y squared minus ay plus 5y minus 3 equal to 0. Let's combine the first two. We have a 2i that multiplies y minus 4. Let me see, let me make sure I did this correctly. Negative 8 and 5 is negative 40, negative 3, so this should work. Okay, let me see. Oh no, yes, I put a negative 3 here, sorry. This is a negative 20. Okay, that's why. Alright, so now we have a plus 5. We can factor out 5, and again we have y minus 4, and this is equal to 0. So now we have a y minus 4 in common, so y minus 4 we can factor out. And then we have a 2y plus 5 equal to 0. Alright, so from which we get two possible equations, y minus 4 equals 0. And the other one is 2y plus 5 equal to 0. So we can solve the first one, which is y equal 4. the second one is if you subtract 5 divided by 2, you get negative 5 half. But we are not done because now we need to replace y with w to the power of 1/3. So we know that w to the power of 1/3 is equal to 4, and from here we have that w to the power of 1/3 is equal to negative 5 over 2. So how do we go from to the power of 1/3 to w? We need to raise both sides to the power of 3. So we get w equal 4 to the power of 3, which is 64, and from here we get w equal to negative 5 half to the power of 3, which means negative 5 to the power of 3 is a negative, well, 5 times 5 is 25, times 5 is 125, and 2 to the power of 3 is 8. So our solution set is going to be, so we got negative 125 divided by 8, and then we get 64. Okay, so these are the two solutions. Now we should check that this solution actually work, and it should work in this case. Okay, but you can double check, plug it in into W, and see if the left hand side is equal to the right hand side. Okay, so we are gonna finish this video with this last practice problem. I strongly suggest you try this by yourself. You stop the video and then you check with me. Okay, so I'm gonna work it out, but please try by yourself first. Okay, all right. So remember, what we want to do is we want to rewrite this in the terms of ay squared plus by plus c equals 0. So c is this 62, b must be this 33, and a must be this 1 here in front. So y must be the number in front of 30, the term in front of 33, which is this one. So this must be y squared. So in our case, y is equal to x squared minus 6. How many solutions do we expect from here? That's a question you should ask yourself. And we expect to get up to 4 solutions because we have an x squared and this is raised to the power of 2. So again, we have a 4th degree polynomial. And now, this in terms of y, I can write this as y squared plus 33y plus 62 equal to 0. Can we factor this? Can we find two numbers whose product is 62 and whose sum is 33? Okay, so we need to get, let me see, two numbers whose product is 62 and whose sum is 33. Okay, well, if we don't find it, in order to see if these two numbers exist, we can start with 1. 1 times 62, which is 62. And these two, so I'm probably trying to factor out 62, right? 1 is 62, but I can also factor as a 2 times 31, right? And notice how 2 times 31 is 62, and the sum of these two numbers is 33. So these 2 and 31 will work, okay? Which means I can rewrite this as y plus 31 times y plus 2 equal to 0. The solutions are y equal negative 31 or y equal to negative 2. Now we come back to the previous substitution. We know that x squared minus 6 is equal to negative 31. And from here we have that x squared minus 6 is equal to negative 2. So we can add up 6 from the first one, so x squared is equal to negative 25. We can add up 6 on the second one, x squared equal to 4. So from here we take the square root, put a plus and minus, so we end up with x equal to plus and minus, square root of negative number is I, so this is 5i, and from the second one, if we take the square root and put a plus and minus, we end up with x equal to plus and minus 2. So what's the solution set? So we end up with negative 5i, positive 5i, negative 2, and positive 2. So 4 solutions as we predicted. Okay? Alright, so and then in the next video I'm going to show you some additional problems about the quadratic form. Okay, and then again I'm going to assign an Alex homework for this. Okay? So just to quickly summarize, Quadratic form does not mean that you are dealing with a quadratic equation, but it's any other equation that can be written in terms of a quadratic equation. Once you solve the quadratic equation in terms of y, you come back to the original substitution, which is this one, and then you solve for x. Okay? Alright, so let me know if you have any question, and I'll talk to you later.